All right, good morning. We're going to start going over the activities for this particular week. And hopefully, what you've already done is read about this chart or this graph. Um, so, hopefully, you've already seen this graph and answered some questions. What this is showing, if you look on the screen here, and you can get a better version on Haiku, a bigger version. But what this graph is showing is how much carbon we're emitting per year. And the amount that we emit per year goes up and up and up and up. We put more and more and more and more. What this graph is showing is that if we can stabilize the amount that we're putting in, so not reducing it, not putting any extra in, but just the same amount that we've put in the past. In this case, this is in 2005, that would have been 7 billion tons of carbon. So if we can maintain that and just keep it 7 billion tons, we are avoiding doubling the amount of CO2, which is this in red. To do that, we would have had to somehow um, reduce the amount of CO2 that we would be increasing, putting it into the atmosphere. If we did nothing and just kept it the same, our emissions would just continue to go up, and we'd be looking to triple the amount of CO2 that we're putting in every year by 2055. Okay, so if we just maintain the amount of CO2 that we put in right now, that doesn't change the amount of CO2 that's in the atmosphere. All we're doing is staying level. So whatever parts per million we had in the atmosphere, we're now over 400 parts per million. If we didn't make any changes, that would stabilize. Okay, it would still be higher than it probably should be, but that would stabilize. So the goal of this activity is to find ways that we can reduce the amount of carbon that we're putting into the atmosphere. And on this next on this next graph that you see now, the stabilization triangle is a little bit bigger. And you notice rather than just leveling off, saying we're going to only emit this much CO2 every year, no more than that, and no less. Now we're saying, okay, well, how would we have to do it to reduce the amount of CO2 that we put into the atmosphere every year? So we take whatever our normal amount is, and now we're going to put in a little less. And what we have to do is we have to fill up this triangle with some methods of reducing CO2. And there's a whole bunch of ways that we can do this. We actually have technology right now and the means to reduce the amount of CO2 that we put into the atmosphere. And what you're going to be doing is finding specific ways to reduce that amount. So you're going to fill up this stabilization triangle, this yellow or orange section. That's going to be our task. Okay, so the way that we're going to do this, if you look at one of the handouts that you're going to get for the week, is this stabilization wedge or triangle. And you see that there are spots, or there will be spots, for 10 different resources, or 10 different small wedges. So each little wedge is going to fit together to make an amount of carbon that we can take or keep from getting into the atmosphere. Not take out, but keep from getting in. The way you're going to find this is you're going to go to your resource cards, and you see up here it says resource card number 1. And this first card is about transport efficiency, and it details how we can keep 1 billion tons of CO2 out of the atmosphere. That's one little wedge, one little piece of that triangle. And if I go to the next one, I have resource card 2. transportation conservation. And it talks about a way to take 1 billion tons of CO2 and keep it from getting into the atmosphere. So hopefully you're seeing the trend here. Resource card 3, building efficiency, and it talks about how we would keep 1 billion tons of CO2 from getting into the atmosphere. And if you go along, you're going to see that there are 15 total resource cards. Every single one of them is a way of keeping 1 billion tons of CO2 out of the atmosphere. So there's 15, but you are going to choose 10 of these. So you're going to have to go through, read them all, see how much they cost. They have a little cost at the bottom. $1 sign is low, and let's find the $3 signs means it's expensive. 2 is right in the middle. So you're going to have to go through these, and you are going to choose 10 of these resource cards or 10 of these methods that will keep CO2 out of the atmosphere. So once you choose these 10, you're going to be writing in each one into the stabilization wedge. Okay? So for instance, if you choose this strategy, transportation conservation, you would be writing in transportation conservation into one of these wedges. So one of the assignments that you're going to see that goes along with these resource cards is this, analysis of your 10 wedges. So you choose the 10 wedges or the 10 resource cards, and then for each one, you have to write a little bit of information. So how does this strategy reduce carbon emissions? So it'll tell you how that particular strategy, if you look here, and you read through, it'll tell you how it reduces CO2 or keeps CO2 from getting into the atmosphere. Okay, so besides the method that it's going to reduce carbon emissions, you also have this here, and if you read that, it says, what are obstacles with implementing this strategy? Give a detailed description of the challenges and ways to possibly overcome the challenges. Think of social, economic, and political challenges. So what's going to keep us as a society from implementing this? Social, there might be social norms or social ideas that go against implementing this strategy. Economic, that's just dealing with money. So are there money challenges? Is it very expensive? Is it not very expensive, but it's going to require some kind of technology investment? These are things that you need to think about. Political challenges. We have a very divided political system right now. Is one side going to support the strategy, but another side not going to support the strategy? Who would or wouldn't support this strategy? So these are challenges that you have to write down, and that's for every single strategy. So you've got 10 different spaces here for your 10 different wedges. It's a detailed analysis.